All right. So permutations with restrictions. So we've dealt with ones with restrictions. So we're going to go over more restrictions. And then we're going to also go over identical events. So in many problems, restrictions are placed in order if its objects are arranged. In this type of situation, deal with the restrictions first. Many of the problems in this lesson can be solved using fundamental counting principle. So we don't have to do the answers both ways. We just have to come up with one way. So I'm fine with that. So how many ways can all of the letters in the word oranges be arranged? So now we're arranging all of them. We have to check, are there any doubling up of letters? No. Oranges is how many letters? 7. And does it say like 4 of the letters or 3 of the letters? No. So 1, 2, 3, 4, 5, 6, 7. So that would be 7. And then this one would have 6 letters because it's letters, right? We leave one behind. If we'd have the whole word oranges here. Then we hold one, then we'd have orange, let's say. Then we hold one, so we'd have 5, 4, 3, 2, 1. Now, when you started a number and you multiply by 1 less than it all the way to 1, you can use a factorial symbol. So this is like 7 times 6 times 5 times 4 times 3 times 2 times 1. You can only do it if you go down by 1 all the way to 1. So if you went 7 times 6 times 5 times 4, you couldn't use the factorial symbol. But because we're going to 1, you can. So type in 7 times 6 times 5 times 4 times 3 times 2 times 1 into your calculator. So when you do that, what do you get? 5,040. Now, we're going to go 7 factorial. Okay? Now, how you get to that is you go like this. On your calculator, you're going to go 7. Then you're going to press math. Okay? You're going to arrow to the left to probability and number 4. Arrow to the left to probability and then number 4. And enter. Same answer, right? 5,040. You can only do that though, like I said, if you go 7, 6, 5, you go down by 1 all the way to 1 though, right? If you only went to like 7 times 6 times 5 times 4, there's no way you can put that in. You'd have to actually type with that. Okay? Another way, because these go down by 1s, like this each goes down by 1, we could also say we have 7 letters and we're picking 7 of them. It's a permutation because it's a word, so we use the P. We have 7 letters and we pick all 7. Now, if they could repeat and we had 7 times 7 times 7 times 7 times 7 times 7 times 7, we wouldn't be able to use this, right? We can only use this because it goes down by 1. How do we use that? Well, you go 7, math, over probability again, P, which is 2, NPR, that's when we're picking NPR, which is 2, and then 7. 7P7. Same answer. So if they have 7P7 or something like that on the diploma, but you got an answer a different way, could you not turn 7P7 into an answer, turn yours into answers and match them? Circle? Absolutely. But you need to know how to push that button or you really can't match. All right. Now the first letter must be an N. So we have to deal with that first. One restriction. And how many letters do we have left? 6. Then. So this would technically be 1 times 6 factorial. Do we need the 1? No, so it'd be 6 factorial, which I believe is 720. All right. We have 3 girls, girl 1, girl 2, girl 3, and 4 boys, boy 1, boy 2, boy 3, boy 4, are to be arranged in a row for a photograph. In how many ways can this be done if there's no restrictions where any person stands? Doesn't matter if they're boys and girls then. If I don't care where anyone stands, does the boy and girl part matter? No. How many of them are there? 7. So I'd have 7 people for this one. Now I'm arranging people in a photograph. And so when I arrange people for a photograph, do I leave a person there and then start arranging someone else? Or do I like arrange all 7 and then say, arrange like, say I have 7 options for here, then pick that person up and don't leave anyone here, and then arrange again? Does that make any sense? No, you'd never have anyone arranged ever, right? So you arrange one person, but we had how many options for that place? 7, but then we leave a person there. Now they're there to take the picture, right? Now we move to the next spot. How many options do we have people to put in this row, in this spot? 6. We leave a person here, then 5, and we leave a person here, then 4, and then we just keep going, right? So we'd have 7, 6, 5, 4, 3, 2, 1. They don't say you can't repeat, but it's people. Twins are still not the same person. If you ask them, they're not like, oh, we're the same person. Don't worry about us. We don't have identities. They're the same people. No, twins are different people. Dana would agree with me on that one. Yes, she would. Okay, so we have 7 factorial, which is 5,040. Okay? The photographer decides that he could take a better photograph or photograph. That's my Saskatchewan slang, photograph. If no 2 people of the same gender can sit together. Okay, we don't want to sit any people of the same gender together. So there are 7 blanks. It doesn't say, hey, we need to start with a boy because there's 4 boys and 3 girls. But it does say, hey, we need to start with a boy and then go with girls because they don't want any genders together. And if we start with a girl, what's going to happen? Girl, boy, girl, boy, girl, boy. Crap. That's what's going to happen. Bad things. Yeah? So they're not saying we need to start with a boy, but they're telling you we need to start with a boy. So we have boy, girl, boy, girl, boy, girl, boy. Now I do them separately, so I'll do the boys as green because I don't know why. I felt like it. So how many boys do I have for this spot? Then the last lonely boy just stands there. Okay. Now for the girls, I'll do them in red. I don't know why. Because I picked it up. Okay. What color is green? Green. It's a color. It's a shade. It looks like that. Now, good little life lesson for you there. If you're colorblind, you probably can't see it, think it's purple, but whatever. Green girl. Oh my goodness. How many girls? 3. My brothers are all colorblind, so be grateful we got Christmas colors and I can tell that. Okay. My dad's colorblind too. So the green ones would actually make 4 factorial, would they not? All the green ones? 4, 3, 2, 1. And the red ones would make 3 factorial. What's that? 144. Now, I'm going to give you one more question. You have 4 boys and 4 girls. How many ways can you rearrange them so the boys and girls are not together? And go. 4 boys, 4 girls. Quickly, put your hand if you start with a boy. Okay, quickly, put your hand if you start with a girl. Why is that an issue? It is an issue. If you start with a boy, and then you don't start with a girl, let's say, right? You have 4, 3, 2, 1. 4, 3, 2, 1. Is that the answer? No, because that is a different arrangement than if I started with a girl. There's actually 2 cases here. You have to add another case if you start with girls, because if you're telling me that this looks exactly the same as this, you're telling me if I did this, you wouldn't be able to tell the difference. Would you be able to tell the difference? Yeah. So 4, 3, 2, 1, 4, 3, 2, 1. So it would technically be one of them times 2. Yeah? This one people don't do as well. This one everyone does really well. This one everyone gets half of it. What are they going to have on the diploma? That answer. Not right, but they'll have it there. And then they'll have the correct one, but you won't go to it because you got your other one. You're happy, you see it, and it matches, and you're like, yay. Okay?